In Part B, we need to find the probability that at least 3 of the 5 people are audited. We can use either the binomial probability formula or a new statistical function called binom CDF. The C in CDF means cumulative from 0. More about that in a bit. Let's see what we would do if we want to use the formula. We would need to find the probability of at least 3, which means the probability of 3 or more, which is equal to the probability of 3 plus the probability of 4 plus the probability of 5. Now in Part A, we just found the probability for 3. That was 0.0000980. To find the probability of 4, we would need to find 5C4. The probability of success is 0.01. The number of successes is 4. The probability of failure is 0.99. The number of failures would be 1. To find the probability of 5, we would need to find 5C5. Probability of success is 0.01. Number of successes would be 5. Probability of failure would be 0.99, and the number of failures would be 0. When you work all of that out on your calculator, you should end up with 0.0000985. Now let's talk about using this new formula, or this new function, binom CDF. If we wanted to find at most x successes, we would need binom CDF. In parentheses, we would need the number of trials, which is n, the probability of success, which is p, and the number of successes, which is x. So when we use CDF rather than PDF, it actually finds the probability of 0 plus the probability of 1 plus the probability of 2, all the way up to the probability of whatever x is. However, in our case, we need to find at least 3 successes. So, in our case, we will need to also use the complements rule. Keep in mind that since we want to find the probability of selecting at least 3, that means P3 or more is equal to the probability of 3 plus the probability of 4 plus the probability of 5. If we're using the complements rule, we could also find the same probability by taking 1 and subtracting what we don't want, which would be the probability of 0 plus the probability of 1 plus the probability of 2. That would leave us with the probability of 3 plus the probability of 4 plus the probability of 5. Now keep in mind that binom CDF adds the probabilities from 0 up to whatever number we need. So here we can replace all of this with binom CDF. And the number of trials is 5. The probability of success is 0.01, and we want to go up to 2. So there it is. We need to find 1 minus binom CDF 5.012, and when you work that out in your calculator, you should end up with 0.0000985. So it's a little bit shorter than using the formula, but we did get the same answer.